Hello friends, my name is BKK Kolhapure. Today we will take up the dynamics part of the engineering mechanics where we will be studying about work, power and energy. So these three parts we are going to study. Let us begin with the work. Now we will see if I take a body and if I keep it on a surface and if I apply force to this, the body will be displaced or moving from one point to another point. We say the force is doing work here. So what is work here? Suppose if I take a body on a surface, if I apply force to this, then along the surface the body gets shifted to some other point. If this distance it is traveling is s, we say this force is doing work, and this work what the force will be doing, we call it as the work done. This is nothing but the product of force and the distance or the displacement that is taking place. Now here if I call work done, I will be calling henceforth as WD stands for work done. So this is equal to force is P here and S is the distance it is traversing. So force into distance. But both should be in same directions. Both should be in same direction. This part is important. Same direction in the sense if the force is horizontal, the displacement is also horizontal. So force is the defined as a product, work done is defined as a product of force into at the distance for which it is traveling, and force and the displacement should be in the same direction. Now if you want to know the unit of this, force unit is in Newton and distance if I call it as meter. So unit of force work done will be Newton meter, or we also call it as joule. So joule is the unit of work done. Suppose if I take a body on a surface, if it is subjected to a force like this P, making an angle of theta with the horizontal, due to this force it will be moving from a distance of s. Now we know work done is the product of force and its distance. Both should be in the same direction. Now if you see to this, the displacement is in horizontal direction but the force is acting inclined. So both has to be in the same direction. So what we'll do, we will resolve this force P horizontally. And if I resolve horizontally, it is going along the angle. We know along the angle is cos theta. Now we know the direction of the force horizontal. We know the displacement in the horizontal direction. So work done for this will be P cos theta, that is the component of the force in horizontal direction and into the distance what it is traveling. So this is the work done by a force acting at an inclination of theta. Suppose if theta is 90 degrees, theta is 90 degrees means this is the body, and if the force is acting perpendicular and displacement is going in the horizontal direction. Now when you substitute theta is equal to 90 degrees, then work done cos 90 is 0, so work done will be 0. The meaning is if the force and the displacement they are perpendicular to each other, force is acting down, displacement is in the horizontal direction, they are perpendicular to each other. If that is the case, no work is done by the force. For example, if I take a weight and keep it on my board head, and if I walk for 1 kilometer, weight is acting down, displacement is horizontal, perpendicular to each other. I am not doing any work here. But if I move just up and down, so the load will be moving up and down. So we are doing the work. So whenever the force is acting perpendicular to the surface, no work is done by the force. So always the force should be in the direction of the displacement. Now suppose if I want to represent it graphically, suppose if I take the coordinates x coordinates and y coordinates, along x coordinates if I represent the displacement or distance it travels, and along y axis if I give the force, and if it is uniform force, means force remain the same for a distance of s. If it is traveling a distance of s, and if the force is p here, then the work done will be equal to, we know it is force into distance. This force into distance is nothing but the area of rectangle. It is the area of the rectangle. Suppose if the force is varying displacement or distance, and this is a force P, yes, if it is varying from P1 to P2 like this is P1 force and this is P2 force, and it is displaced by a distance of s here. So in this case, work done will be equal to average force into distance it is traveling. So average force will be P1 plus P2 divided by 2, that is the average of these two, and the distance what it is traveling is s. So this is a graphical representation of the force when it is uniform and when it is varying. Now based upon this work, we will see some examples. So unit of work done is Newton meter or joule. Let us take a simple problem here. Now here you are required to find the work done in moving the body weighing 500 Newton through a distance of 5 meters along a horizontal surface by a horizontal force of 300 Newton. So you are required to find out what is the work done. Weight of the body is 500 Newton and the force that is applied is 300 Newton and the displacement here is 5 meters. Suppose if I see the surface body, it has got a weight of 500 Newton. It is getting displaced by a distance of 5 meters and a force of 300 Newton is acting here. So in this case, we know work done is equal to force into distance or displacement, that is P into S. But both should be in the same direction. Now if you see to the force is horizontal, displacement is also horizontal, we get directly work done is equal to force is 300 and the displacement is 5. So this will be equal to 1500 Newton meter. Or we also call it as joule. This is the first case. Second case is, what will be the work done if the line of action of the force make an angle of 30 degrees with the horizontal. So second case is, same body having the same weight 500 Newton and here it is being displaced by the same distance 5 meters, but the force acting is inclined and this force is 300 Newton and it is making an angle of 30 degrees with the horizontal. So here theta is equal to 30 degrees. So we know work done is equal to force component into displacement or distance. So what is the force component in the horizontal direction, because displacement is in horizontal direction. If I resolve it horizontally, it is along the angle and it is acting towards right. So P cos of theta into S. So here P is 300, cos of theta is 30 degrees into the distance what it is traveling is 5, and you get this work done is equal to 1299 Newton meter or joule. So this is a simple example showing the effect of force, displacement and the direction. Now here there is a weight of the body is also acting, but the weight is downwards and the displacement is horizontal. They are perpendicular to each other. No work done is by the weight here, only the force is doing the work. Let us take up another problem on work. Now the problem is like this. A man pulls a cart by exerting a steady horizontal pull of 350 Newton and walks at a rate of 4 kilonewton per meter. How much work is done by the man in 5 minutes? So a man is exerting a pull of 350 Newton. He is moving at a rate of 4 kilonewton per meter. We will have to know what is the work done by the man in 5 minutes. In 1 hour, he is moving a distance of 4 kilometers. First, you will have to find out what is the distance he will be traveling in 5 minutes. You know the distance traveled, you know the force he is applying. So, you get the work done by the force. So, here, if you see to the system, P is equal to pull he is applying is 350 Newton. It is going horizontally, and the velocity with which he is moving is 4 kmph, 4 kilometer per hour. So this 4 kilometer per hour will convert it in meters. So this will be equal to 4 into 1000 will be meter divided by 60. This will give in meter per minute. So because here minute is given, we will convert it to minute, or you can convert it by multiplying by 60 also in per second. So we will convert it in minutes. If you simplify this, you get this as 66.67 meter per minute. This is a meter per minute. So in 5 minutes, how much you will travel? So this will be equal to 66.67 into 5. So this will give you 333.5 meters. So he will travel a distance of 335 meters. We know work done is equal to force into displacement. Here force and displacement are in the same direction. So force acting here is 350, and the distance what it is he is traveling is 333.5 meters. So this will be equal to 116,672.5 Newton meter or joule. Or I can write this as, if I divide it by 1000, 11.667 kilo Newton meter, or this will be kilojoule. So here just we have determined how to find out the distance. We will take up some more problems in the next video. Please subscribe to the channel for more videos. Press the bell icon for notifications. Comment for questions in the comment section. Thank you.